And I'm thinking, I see 84 has appeared here and here. Maybe that's the one I'm looking for. Maybe it's not. I still have to do the 63. 42 times 3 is going to be 126. Times 4 is 168. Times 5 is 210. So maybe I'll just go to 210. 63 times 2 is going to be 126. So that 84 doesn't work. These both share 126, but the 28 up here doesn't have a 126 in it, so that's not going to be it. All right, I got to keep going. 63 times 3 is 189. Do they have 189? Nope, none of the others do. 252. I'm up to past the other ones already, and I still haven't found a common multiple of them. So maybe I'm going to go back to my 28 and my 42 and see if I go a little bit higher what I end up with. So 224. The next one, if I add another 28 on there, I get 252. How about this one? If I add another 42 on there, I get 252. So I see that all three of these terms will eventually multiply to 252. Is there any number that was smaller than 252 that they all three multiplied to give me, or multiples of them would give me? There isn't any. This 84 appeared here and here, but it didn't appear in the 63. 126 appeared here and here, but not in the 28. 168 appeared here and here, but not in the 63. So the only one that works is the 252, because all three of them will eventually multiply to 252, and that's the smallest one. So that's one method. I kind of took a long time to do that, but it's kind of a method that will eventually get you there, but it can be really messy because sometimes you'll be dealing with really large numbers. So that's method 1. This is method 2. And we're going to use prime factorization. We're going to take the greatest power of each number and multiply them. So this might not make a lot of sense right now, but we'll get there. All right. My three numbers. I had 28, I have 42, and I have 63. I'm going to take factor trees for all of these things. So this is where you get to test your math skills and how good you are at multiplying in your head, breaking these things down. 28, it's going to be 4 and 7, and 4 is 2 and 2. So there we go. It's factored to primes. 42, a bunch of different ways you could break that down. I like 21 and 2. 21 is 7 and 3. 63, 9 and 7. 9 is 3 and 3. All right, I have figured out what my prime factorization looks like. I'm going to write this like this. 28 is equal to 2 times 2 times 7 which is the same thing as 2 squared times 7. 42 is equal to 2 times 3 times 7. And 63 is equal to 3 times 3 times 7, or 3 squared times 7. Alex, you're asking a question. 2 squared times 7 is 28. Why not write 28? The idea here is that we need to break down the prime factors of these numbers to figure out the least common multiple. So it's kind of a means to an end. We have to figure out what the prime factorization is before we can figure out the least common multiple. So if I go back up to kind of how I defined what we were going to do here, method 2. It's use prime factorization and take the greatest power of each number and multiply them. So I'm still trying to find the least common multiple of these two things, the LCM. I'm going to take the greatest power of each number. So I'm looking, I see 2. Okay, what was the greatest power of 2 I had? I see I have a 2 squared here. So I'm going to steal that 2 squared. And I'm going to start with 2 squared. And then I had a 3 squared over here, so that was my 3. And then what else did I have? I had a 7. Are there any factors I missed? I have a 2, I have a 3, and I have a 7. That's it. The greatest exponent of 2 was 2. The greatest exponent of 3 was 2. The greatest exponent of 7 was 1. If I had another prime in there somewhere, like a 11 or something, I'd include it, and then whatever exponent it had. So what is 2 squared times 3 squared times 7? I don't know that off the top of my head. 2 squared is 4 times 9 times 7. It's going to be a big number. What do you think? What did we find was the least common multiple up above in the first method? These things all multiply together to give me 252. And that is exactly what I had from method 1. So maybe that kind of helps you out a bit, Alex. Just a way to get to where you need to go. So, you know what? In chat, I want you to write which method you like better. Did you like method 1 better or method 2? Just need to put in a number, 1 or 2, and then hit enter. What do you think? 1 or 2? 1 or 2? 1 or 2? Chloe's going with method 2. Taylor likes method 1. Not sure yet. You're undecided. So there's no right or wrong way to do this. I will tell you that method 1 is easier for smaller numbers, but when you get really big numbers, like find the least common multiple of 733, 421, and 5,000. The numbers get really big really fast, and it kind of just is a bit messier, I guess. The second method will always work, just factor trees and go from there. So I think the general consensus among the class is that 1 is maybe looking a little bit easier. And I mean, you can do it either way, you'll end up at the same spot. So the second method is probably a little bit faster, and you'll eventually kind of maybe learn to love method 2. Method 1 works, and that's probably what I would do. Isn't the lowest common multiple for all numbers 1? You're kind of getting mixed up with multiple and factor. The a factor that goes into all numbers is 1? Yes, because all numbers are divisible by 1. But when we talk about multiple, like multiples of 4 would be 4. So 4 times 2 is 8. Then we go 12, 16. So multiples are taking that number and multiplying it. So if I wanted the lowest common multiple of 4 and like 12, I'd go, okay, 4 times 2 is 8, and 4 times 3 is 12, and 4 times 4. And then I do the same thing with 12. I go, okay, 12 times 2 is 24, and 4 goes into there. So the lowest common multiple for those things is actually going to be bigger because we're multiplying them. If we're talking about factors, we're going smaller. If we're talking about multiples, we're getting bigger. Kind of a bit of a different idea. Next thing here is talking a little bit about algebra tiles. Now, maybe I shouldn't say this, but I'm going to because I just am going to. I hate algebra tiles. Put a green check in chat, please, if you have used algebra tiles before. And if you have no idea what I'm talking about, you can put in like a red X or something like that. So just in chat, green check if you've used algebra tiles before. Looks like we have a few people that have used them. For those of you who didn't put in green check marks, could you put in a red X if you've never heard of algebra tiles before? Just so I get a bit of a feeling for where we're kind of at with the class. Algebra tiles, never seen them before. These are them over my my right shoulder here. It's kind of, it might be a sign of the time that I learned math. It was just something that, you know, I never saw. And when you get into the like younger math grades, you know, I think 6, 7, Math Makes Sense textbook, they have algebra tiles in there, and they actually are in the grade 10 curriculum. And they actually have questions on provincial exams using algebra tiles. They'll have these algebra tiles there for you, and they'll ask questions about like diagrams of algebra tiles, like what polynomial does this represent, or things along those lines. So in chat, it's looking like we have, can't read the number, about half the class has seen them before, one person's never seen them, and then the rest are off in their living room watching TV maybe. So about half of you guys have seen them, which is probably about normal. I strongly dislike them. I don't think the amount of time we put into teaching you guys how to use them is valuable in terms of what you'll get out of them. If you move forward with math into grade 11 and 12, generally speaking, you won't see them a lot again. And some of the things we do in grade 10 math, using them, the rules actually don't apply. The rules of using algebra tiles don't even work for factoring sort of negative numbers and things like that. So I find some students really like them because they're maybe visual learners and they kind of make things easier, break things down for you, make life easier. I personally believe that they just make your life harder. Maybe that's just because of how I learned math. I'm sympathetic to those of you who like using them. I think it's a great way of visually showing how to do math, which is perfect, but I don't love them. In fact, I asked a bunch of other teachers if I could borrow a set of algebra tiles over at our other building, Central, and none of them had them at the other building. They don't even have them over there. They just, don't really get used that much, and very few students generally like using them. So if you want to do some algebra tile stuff, go for it. I'd be happy if you want to express these things using algebra tiles. I don't have anything wrong with that. You can use them. In fact, I can pretty much guarantee at least one question on your provincial exam will have an algebra tile type question in it. I'm not going to spend a ton of time talking about them or using them because I don't think they're very valuable here. So this is just my opinion, and I apologize if you love them and you think you're going to benefit a lot from them. Maybe we get a little bit further into factoring polynomials, sorry. Maybe I'll show a couple examples of them, but for now I'm just going to kind of breeze through them. You'll see in the learning guide they actually do appear, And if you want to do some questions with them like that, by all means, go for it. But I'm not going to insist that you use them. So that's just kind of how I feel about them. And if you want to use them, there's nothing wrong with that. I don't have an issue with that. So take it for what it's worth. I'm going to skip this little guy here. This actually starts to get into factoring just a little bit. And maybe I'm just going to leave it there for today. Because I don't really want to start this whole factoring thing right away, because this is kind of the meat and potatoes of Unit 4. So I've kept you guys a few minutes late yesterday. I'll let you out a few minutes early today. Today's Tuesday, so you have English at 11:30, so in about 15 minutes. And we're just going to leave it there. In terms of the learning guide, how far did we get? You can see the next section, algebra tiles. I'll go through the answers to these if you guys want. If you don't want to do them, then I guess you don't have to, but they do come up on the provincial exam, so it's worth at least going through these. So maybe we'll go through those when we have some time later on. Expanding special polynomials should be good. We've done examples of those things. So you should be up to page 8 now. This is lesson 4, should make it up to page 8. Yes, Abby, I mean 10:30. Sorry, I looked at the end time, not the start time. So learning guide, you should be up to page 8. I understand you're probably preparing for the midterm. When I think about the midterm, you guys have already learned all this stuff, so I don't want to spend a ton of time, but I will dedicate as much of tomorrow's class as you need to going over the learning guide for the midterm review. So whatever you guys want me to do next day, I'll just say Unit 4 is on the back burner for now. Whatever you want to learn, relearn, go over from the first 3 units, 1, 2, and 3, and then the beginning stuff of 4. I'd be happy to do that. So that's kind of what we'll do next day. So I'm going to dedicate the whole class to that. Alex, I will go over that next day. I'm just going to do problems all day next day. I let you guys, or I kept you a bit late yet last day, and I'll let you out a bit early today, so it all kind of adds up. So there you go. That's all I want to say for now, and I will see you guys tomorrow, and Mrs. Ward will be on shortly at about 10:30. So have a good afternoon, guys, and we'll see you tomorrow.